Okay, what do you do when you're making a 30-minute video and you have to cough, a certain number of minutes into your video? So sorry this is split. Let's keep going. See? Okay, this one's going to be different. So now we have 3x to the 0 power. Okay, so now I have parentheses. So that means that both of these items are within that parenthesis and the whole thing is to the 0. There's the difference. So you really have to watch for your parentheses. I can have a more complicated version of that. I could have 4x squared y to the 5th all to the 0. Still equal to 1. I could have a fraction. The whole thing's to the 0 power, it's equal to 1. I could have, now this one's tricky. So the difference between example F and example G, and then I'll put this to rest, is that you have to watch where the negative sign is. So here, if you have negative 6 to the 0 versus negative 6 to the 0. Once again, this kind of goes back to the same idea I touched on over here. On this one, well, let me do this one first. On this one, that negative is, again, inside that parenthesis, so it's that whole thing to the 0 power, so that's going to be equal to 1. Here, mathematically speaking, go back to those, please excuse my dear Aunt Sally, if you put your hand over that negative, because it's really like negative 1 times 6, okay? It's 6 to the 0 with a negative in front of it. That negative is not being raised to the 0, like that negative is not attached to the 6 when it's being raised to the 0. So we have negative 1, and then this part becomes 1, and so that's negative 1. And if you remember these things from past math classes, they might seem easy, but if it's been a while, then those things can be kind of overwhelming, and you might need to pause and go back and rewatch several times. Okay. Last rule. And then there is, if you know what's coming, if you're familiar with all the exponent rules, there's one more, but that is part of actually section 4.2. So the last piece of section 4.1 is called the power rule. All right, and the power rule says this. A to the m raised to the nth, and we multiply them. Okay, so if you raise an exponent to another higher exponent, then those exponents get multiplied. Here's why it works. If you have a squared to the 3rd, what does that mean? Well, let's take this outside exponent first. It means that you have multiplied a squared by itself 3 times. So you have a squared times, I don't know why I use parentheses, a squared times a squared. What does that mean? Well, a squared is a times a. Maybe you already see where I'm going with this. And so each one of those is a times a. How many times did I write a down? I wrote it down a total of 6. So that's what that means. Let's look at some examples. So the first one, we have 4x squared to the 3rd. All right, notice how I have both a constant and a variable piece. And so let's deal with that 4 first. That coefficient in front is still being raised to the 3rd power. And so it's really saying, okay, we have 4 to the 3rd multiplied by x squared to the 3rd. This is just one way. The thing with exponents is sometimes there's more than one way that I could choose to kind of explain. So when there's a coefficient, you just apply that exponent. We're not going to leave that as 4 to the 3rd. We're actually going to figure that out. So I would have maybe, you can get it online, obviously, some online calculators, but I like to use a nice scientific TIs are relatively standard. I also teach high school at Peoria High School, and we use the Casios. So if you came out of PUSD at all, you're probably more familiar with the Casios, whatever you guys like to use. If you want advice or how to obtain one cheaply, if you need advice, feel free to email me. How to obtain one cheaply, I would go to OfferUp. I like that better than Craigslist. Like whatever you guys like for kind of your used shopping. I found one that normally retails for maybe $150. A couple years back when my daughter was a freshman in high school, so this is going back like 6 years now, but the calculator is still fully functional. And we paid maybe $20, $25 for a $150 calculator. And it was even pink and sparkly and fabulous. All right, so here we are. You can put this into the calculator if you want. 4 to the 3rd power, you would just put it like this, use that little exponent key. All right, you could do 4 times 4 times 4. I would be familiar, I'll speak on this often, I would start familiarizing yourself with some of those perfect squares and perfect cubes. The more you can just have recall on that and not be dependent on that technology really does come in handy in future chapters. So 4 times 4 times 4 is 64. And then x squared taken to the 3rd power, we're going to multiply those and come up with x to the 6th. All right, let's do our next one. What happens if we have a negative with that coefficient? Feel free to pause. Here's another idea. Feel free to pause maybe when I throw up a different example. Try it on your own and then start the video back up again. Or leave it alone, go to just the example pieces and then see if you can do them and then maybe watch and see if you got the correct answer. All right, so here, this negative is inside that parenthesis. So we are gonna do -5 squared. We're gonna make sure we apply that squared to the -5. So -5 times -5 is 25. And then I'm just going to apply the product rule, or the power rule, excuse me, to the y. So 1 times 2 is y squared, and 3 times 2 is z to the 6th. Example C, I could have multiple parentheses going. So for instance, I could have b squared c to the 3rd, and then b to the 4th, c to the 3rd squared. All right, I really upped the level of difficulty here because I've got a lot of different, I have the variables written down more than once. I've got lots of exponents. I would do each piece separate. So let's take care of this first. So we are going to apply that exponent to both of these. So 2 times 3 would leave us b to the 6th. 1 times 3 would be c to the 3rd. You can put that in parentheses. You don't really need to. You'll see why in just a second. B to the 4th squared. 4 times 2 is b to the 8th. And 3 times 2 is c to the 6th. Now, we're not trying to add these. This whole thing is still multiply. You can put a little multiply there to kind of separate those if you wish. So b to the 6th and b to the 8th, these are now going to combine for b to the 14th. And 3 and 6 are going to add to c to the 9th. And that is our final question, or our final answer. All right, I'm going to do one with a fraction. So 3a to the 4th over b squared. And I put that to the 3rd, and this is example D. And so I'm just going to do the same thing as I would have before, except for my answer is going to be in fractional form. So if it started in the numerator, it stays in the numerator, and then same with the denominator. So 3 to the 3rd power, 3 times 3 is 9. 9 times 3 is 27. 4 times 3 is 12. And 2 times 3 is 6. You guys try one. I'll use a combination of some of our different rules here. So you guys try one that looks like this. How about that? Notice I didn't give you a y in the second term, so I was trying to make it a little easier, and then it might have added a level of difficulty because you're like, where's the y? So, okay, so pause. And here we go. All right, so I would apply this 5 to both of these pieces, so we would have x to the 20th, y to the 15th. Over here, we're going to apply that piece and get x to the 8th. So that's using this rule right here, that power rule. And then just like the one I had, I think it was example C, I now need to combine. I only ever want one variable, each variable once in my final answer. So these two can combine. We're trying to make our answer as simple as possible. So 20 plus 8, we have x to the 28th, and then y to the 15th. Let's do another one. Let's try one that looks like this. Let's do x to the 6th. Y squared over x to the 8th. All right, so I know some of you, when you see the fraction, you're probably like, oh my gosh, that's when I don't do math. I don't like fractions. This class has lots and lots of fractions, and you're gonna have lots and lots of videos to watch me do them, and my math lab also has them, so those are just not gonna go away throughout our whole class. We're gonna apply this part first. We're gonna simplify what can be simplified first. So if you think about your please excuse my dear Aunt Sally rules, or PEMDAS, we're gonna deal with that parenthesis exponent piece right up here. So we're going to apply the power rule, and then we're just going to rewrite the x to the 8th. And now I'm going to say, are there any other rules I can apply? Is this as simple as it gets? And the answer is definitely not, because I can simplify the two x's there using the quotient rule. So 12 subtract 8 is x to the 4th, and then y doesn't have anything to combine with, so we just leave that at the end, and this right here is our final answer. The thing with these exponent simplification problems is that a lot of the questions are they look a lot different, and so it can seem confusing at first because your next problem isn't necessarily going to look like this one or this one. And so then you go, oh, we don't have an example like that. So go back to the rules and think about which rule applies. Think about, please excuse my dear Aunt Sally. And remember that your final answer should only have each letter listed once. And everything else, you should be able to find some type of rule to combine them in some way. So that's 4.1. Reach out to me with questions, and good luck.